You know that feeling, right? Staring at your code, maybe it's 2 a.m.,
Mm.
surrounded by energy drink cans, print statements everywhere, just asking why. We've all been down that debugging rabbit
Oh,
hole.
yeah. Hours and hours, sometimes days.
Exactly. But what if those late nights could, well, maybe not vanish, but become way less common? Today, we're diving deep into intelligent debugging, powered by AI. It sounds like it holds massive potential, really.
It really does. Think about the sheer amount of developer time globally that just goes into fixing bugs. If AI can claw back even a chunk of that, well, that's huge. More time for building, for innovating.
Right. So in this deep dive, we want to unpack how AI is actually doing this. We'll
Ah.
look at the main kinds of tools popping up. Smarter static analysis, more insightful dynamic analysis.
But that really fascinating predictive stuff, too.
Yeah, predictive debugging. Plus, how AI is beefing up security, finding those vulnerabilities early. And we need some real stories, right? We'll get into examples where AI actually cracks some tough bugs.
Definitely. And underpinning all of this is machine learning, essentially AI algorithms learning from just vast amounts of code, bug reports, that kind of data.
Without being explicitly told, look for this specific error.
Exactly. They learn the patterns, predict potential problems in ways older rule-based systems just couldn't.
Okay, let's break that down. These AI debugging tools. You mentioned categories. Static, dynamic, predictive. Let's start with static. Now, most of us have used linters, right? Basic static analysis, finding issues before runtime. How's AI changing that game?
Well, traditional static analysis is great, but it's mostly rule-based, checking syntax, style guides, maybe some basic known pitfalls.
Mm.
AI, especially with deep learning, goes way deeper. It trains on enormous code bases, learning these really subtle correlations between code structures and, say, null pointer exceptions or resource leaks, even concurrency issues.
Before you even run the code.
Before you run anything. It's like having this super experienced editor who doesn't just see typos, but spots potential logical flaws, architectural weaknesses, just by reading the blueprint, so to speak.
Wow, okay. So it's understanding the intent and potential pitfalls, not just the syntax. It's a big leap. All right, what about dynamic analysis then? If static is the blueprint review, dynamic is watching the building in use. How does AI help there?
Exactly. Dynamic analysis watches the code execute. Traditionally, that means, setting breakpoints, stepping through, which is slow, and you kind of need to know where to look already.
Yeah, tedious work sometimes.
Right. AI brings this intelligent observation to the table. It can monitor tons of runtime data, spot weird behavioral patterns, anomalies that signal a bug, even if you weren't specifically looking for that anomaly.
Ah, okay. So it's better at catching those weird state-dependent bugs, the ones that only happen on Tuesdays when the server load is high.
Precisely. The classic works on my machine bugs. AI acts like this incredibly vigilant observer, noticing subtle hiccups in execution that a human might totally miss, especially in complex systems.
Okay, that makes sense. Now, the one that sounds a bit like magic, predictive debugging, predicting bugs before they happen. How does that even work?
Yeah, it sounds futuristic, right? But it leverages, again, machine learning on massive data sets. Think GitHub repositories, huge bug tracking histories.
All that historical data.
Exactly. The AI learns patterns in code that, historically, have often led to bugs later on. It's looking for those known precursors to errors in new code.
So it's like seeing a structural pattern in a building design that often caused issues in older buildings.
That's a great analogy. It's still, relatively early days for predictive debugging. But the initial research is pretty promising, especially for things like concurrency bugs or memory issues. It's spotting potential flaws with decent accuracy.
But not a crystal ball.
Definitely not a crystal ball. It heavily depends on the quality and the sheer amount of training data. But imagine your IDE warning you, hey, this pattern you just wrote, statistically, it often leads to a deadlock down the line.
That alone could save. Countless hours of banging your head against a wall.
Okay, shifting gears slightly, but related security. You mentioned AI as a vigilant security guard. How does that play out in debugging?
It's that pattern recognition capability again, but focused on security flaws. AI trains on code with known vulnerabilities. SQL injection, cross-site scripting, buffer overflows, all the usual suspects.
Right, the OWASP's top 10 kind of stuff.
Exactly. It learns the code structures, the data flows associated with those attacks. So AI tools can then scan your new code and flag those dangerous patterns before they get exploited.
So it's finding them way earlier in the process.
Which is critical. Fixing a security hole during development is, orders of magnitude cheaper and less risky than patching a live system after a breach? It's about building security in from the start. A huge advantage for risk reduction.
Okay, this all sounds fantastic in theory, but let's talk brass tacks. You mentioned real-world cases. Where has AI actually, saved the day with a complex bug?
Oh, absolutely. These stories are starting to surface more and more. There was one well-documented case, a big distributed system. It kept crashing. Intermittently, hard to reproduce. The whole nightmare scenario.
The worst kind.
Yep. The human dev team spent weeks, literally weeks, digging through logs trying to trace it, kept hitting dead ends.
In there.
So they brought in an AI debugging tool. It analyzed the system's behavior, chewed through mountains of log data, and within hours, it pinpointed this really subtle race condition that was the culprit.
Hours after weeks of human effort.
Hours. Saved the massive downtime, freed up developers. It's humbling almost. Shows the power of analyzing that complexity at scale.
Wow. That's a serious ROI right there. You had another example, too, involving logs. Yes, log analysis is a prime area for AI because humans just can't process that volume effectively. In another case, a company had system instability, couldn't figure out why.
Just flaky behavior.
Right. They deployed an AI log analysis tool. It sifted through everything and found this faint, recurring pattern of errors hidden in the noise. Turns out, it indicated an impending hardware failure on a critical server.
No way.
Yeah. They replaced the hardware proactively before it caused a major outage, prevented a huge disruption, so it's not just code bugs, but underlying infrastructure issues, too.
That's incredibly proactive, much more than just finding a typo in the code. Okay, so these tools are clearly powerful. How do we actually get them woven into the daily workflow, making them standard practice?
Yeah, that's the key, isn't it? Seamless integration. Ideally, these AI capabilities need to be right there in the developer's environment.
Like in the IDE itself.
Exactly. In the IDE, giving real-time feedback as you type. And crucially, integrated into the CI/CD pipeline, the automated build, test, deploy process.
So every code commit gets automatically scanned.
That's the vision. Every commit gets analyzed for bugs, for security flaws, automatically. Feedback comes back fast, right in the developer's tools. You catch things early.
Which is always cheaper and easier than finding them later in testing, or, yikes, in production.
Way cheaper, way less stressful. It shifts the focus towards prevention, catching issues almost as they're written. Are there specific platforms or IDEs where this integration is, working really well already?
That paints a picture of a much more, robust development cycle. Less firefighting, more building. Okay, looking ahead then, where does AI and debugging go from here? What's the next evolution?
Well, given how fast AI and machine learning are advancing, the future looks pretty exciting. We can expect AI tools to get smarter, right? Moving beyond just finding bugs to actually suggesting the fixes.
Like suggesting the actual code changes.
Yeah, potentially. Or maybe automatically generating really good test cases based on the specific potential issues it finds. Think about that level of automation.
It would be huge.
And maybe the most exciting part. AI learning from mistakes across millions of projects globally, building this collective intelligence to prevent entire classes of bugs from even being introduced.
Sort of like herd immunity for software bugs.
Kind of. The future of debugging really does look intelligent, proactive, and increasingly automated.
Which frees up developers to focus less on wrestling with errors and more on, creativity and innovation. Building cool stuff.
Exactly. It's about building more robust, more secure, more reliable software ultimately, which benefits everyone.
So just to wrap up quickly, we've seen AI really stepping up debugging sophisticated, static, dynamic, even predictive analysis. It's a massive boost for security too, catching flaws early.
Those real-world examples show it's not just theory, it saves real time, real resources.
Right. And integrating it into CI/CD pipelines points to this future of proactive bug prevention. It makes you wonder, doesn't it? Consider how this AI-driven approach could fundamentally change the speed, the reliability, the security of basically all technology development in the coming years.
It's a profound shift.
It really is. Well, thank you for taking this deep dive with us today into AI and the future of debugging. It's a fascinating space to watch.